I'm not capable of producing recommendations on populations because I just don't know it. And actually, that was my third point that I forgot earlier. An argument can be made that any field has tremendous in-field variability in the soil. Okay, so what these new systems do is that they can react to the conditions of the field, maybe real time, but for sure you can do a prescribed set of approaches. You set regions in your field, areas in your field that you're going to be changing the seeding, the planter parameters or settings on the fly. We all know. You start in the morning with all your energy, set your planter at the beginning, and depth and everything else, whatever you set. But that setting is not going to be optimal hours later, and not only because of time, but you are in a different part of the field. Okay, so that is my argument. Why would this be a good valuable set of technology? All right, now let's review the components. So I'm going to skip number 1. Again, all I'm telling you is that is changing seeding rates is a possibility, very easy to do. Number 2 is something related around to my question to you earlier, is that how we do weight transfer to improve penetration, or the opposite, to reduce compaction by the gauge wheels too, because in our soils, that is not here for sure. But that's number 2, and I'll explain more. Number 3, it is a newer system to change the depth setting. Most of you are familiar with this system. In the back of the planter, you have this lever that you pull, and then you turn sideways, right? So that's how you go to set your depth. That's what you do at the beginning, right? In this case, that lever, that mechanical element is replaced with another mechanical element, but this is an electric motor. So it can then change that on the go as you need, okay? So I'll concentrate the rest of my talk on points, components 2 and 3, but let me finish on describing the components. There is in number 4, a display HMI unit that it has to be a way to interface with these new systems, okay? So this is a component that has to be there for operation. Now, the newer systems are isobus compatible. So that means that at some point you can use your guidance system, whatever is Trimble or John Deere, plug in your new harnesses, and it'll work that way too, okay? But for now, let me just say, you have to have a way to interface with the system. Enter. Okay, so at the bottom, you have 2 pictures, and this is how we do our research in Maricopa. The picture on the bottom left is just a tractor with our planter, and from this distance, I don't see anything special on it. But all these components are in this tractor and in the planter too, all of them. Now, on the bottom right corner, there is a picture of plants and 2 green boxes on top of it. That is the way we evaluate our stands. Okay, we are very limited in manpower, as I mentioned earlier, just 2 guys doing this. So what we do is we scan these lines, 200 feet long treatments, and then we see the reflectance, and based on that, we do an evaluation. We cannot afford to have people counting and doing things in the field. Same variety, planted the same day, Karen, irrigated, everything was treated the same except the planter parameters. That's an excellent question and good segue to the back of my handouts. So on the top, and this is, I'm going to part this as more time as I have left, but this is 2019, 2020, and 2021. Okay, just to give you a sense, I'll talk about 3 topics that are different within the precision planting. So on the top is the work that we did in 2019, and this is very much related to Ron, what your answer, and forget the name of your Robert, but Robert responded. This is the use of a passive system that is just suspension airbag that is it's pressurized, and that way it moves the shank and the rest of the unit down into the soil. So what you see in these graphs are 3 different types of soil compactions that we treated: the 45, 31, and PSI. And just by changing the pressure on the airbag, it's translated into a force, and that's why I use pounds here from nothing, we go from the airbag to be deflated to fully inflated, and that translates to 330 pounds. Okay, so notice how, regardless of your setting, regardless of where you put that depth setting, the actual depth of the seed will change, right? It's an observation that all of you have made. I'm not telling something that is new, but I'm documenting it to make the point to say, how can we use that information, that knowledge, and improve our efficiencies, right? Because it's not going to be developed, a seed will not be, a plant will not be developing same if it's 1/2 inch or 1 3/4 inches. 2020, this is the graph and the picture on the middle. How much time I have? 5 minutes, okay. I'll finish on time. So on this set, what I am trying to communicate here is that use of this up and down weight transfer. So let me describe it a little bit more. For this to operate, you have to have weight available in the planter, whether it's on the toolbar in the front. That's probably the best position, because these cylinders, these hydraulic cylinders, will operate. They'll transfer the weight to the row units, but they have to come somewhere, right? And that is from adding ballast weight to mainly to the toolbar in the front. Okay, and after that, it is programmed on the display to set whatever force you want to add. And this is an active system, different to the airbag, a passive system. In the active system, it goes up and down, and it's monitoring, has a force transducer as a feedback, and it's measuring that, and it's always adjusting. Okay? So the main point of this graph, this bar graph, is to tell you that there is an optimum. If you change those levels of downward force, at some point you're going to reach a optimum condition for growth, right? And this is because excessive force will create compaction, and those roots of seedlings that are very, very small, very tender, they will not develop well. Okay? And the same is if it's too loose, then it loses moisture and the right conditions. So there's a happy medium. And in 2020, we found that adding 90 pounds weight transfer. Okay? The axis on the vertical is that it's a spectral index, which is unitless. So I'm not going to spend time explaining what that index is. Only to tell you qualitatively, the higher the number, the greener and the bigger the plant is. Okay, and last is the graph and pictures at the bottom. So first, let me explain. Those pictures indicate that we did a factorial in 2021, changing the downward force values because we set them. It's in the screen. We just put whatever numbers we want, I'm sorry. And the other is the depth control setting. That's illustrated by this part, okay? This little photograph here. So now we have factorial. So that means we have 20 different treatments. It's a 5 levels of downward force and 4 depths. And the plot here, it shows you, I'm going to rephrase to what Randy said. When you look at trends, your information, your interpretation is much more stronger, right? So what you see here is that from the time that there was emergence, there was little difference between those treatments, right? But as time goes on, and by the way, I'm sorry for the scale that is not very clear here, but these are days after planting. And as time goes on, you see that there's a higher level of differentiation between treatments. And now what I did last night is to give you a sense what that spectral index means, because I mean, what I myself don't understand what that is, but to translate it, those treatments that are on the top that are separating even more from the rest, by the time that we did this this sampling, the height was 9¼ inches tall, and the dry biomass weight per plant was about 5.7 grams. Okay, above ground. Yes, good point. Yeah, thank you, Peter. Yeah, we have above ground and the roots, and as we speak, samples are in the oven, so I don't have the rest of the values. But I picked some for today. At the bottom part of those functions, where the treatments that were treated not optimally, we have 2 inches, plants that are 2 inches smaller on average, and a substantial decrease in biomass. Okay, and this is grams of dry biomass. So have 2 grams, it's a lot of difference. Okay, I'll stop there. That's really all I have. But I'll say, yeah. Okay. Yes. Yeah. The question was, is at the top portion of the graph with the highest index values, mean the better, the larger plants, what combination is to depth and downward force? Okay, all those at the top are the same depth. They're just a different downward force. What that means is that depth is by far the first factor in your it carries the largest response by far. Okay, but within that depth that you target, then there is how you treat the soil. Okay, what's the final mechanical state of the soil that will induce more development? Tilt, yes, yeah. So the comment was from Bruce that they call it tilt, and that is a mechanical state of the soil, because very important and very difficult to quantify. Even definition of tilt, what is tilt, is not defined in engineering terms. But Bruce, the point is very important, because we prepare the ground prior to planting, whichever way we do. And then we come with the planter, and we're gonna add more loads, more mechanical loads, right? And it is expected that mechanical condition of the soil will have an impact on the development of the roots. Exactly, Bruce. Exactly, Bruce. You're exactly right on. And I will add this. The challenge is how we can quantify that in engineering terms, so we can develop recommendations or develop some way to have a guideline, right? Because what you said, just the way you describe them, Bruce, they're qualitative, right? Yes. Correct. I had time, I can use that as a learning experience. Do I? Okay, so to that case where somebody needs to be in the middle of the field making those adjustments, just manually. Imagine the cost of that. Right? This is a grower himself having to do that because it has a return on his effort. So, and what I extract out of that is, that that's known factor. He knows where to sit and wait for the tractor to come back, right? So we can prescribe that. Okay, the other factor that Randy alluded to is that these systems is not reflected in any of these components. I'll bring that next time, but that is the seed firmer in the center of the opening discs, right? It presses the seed, but there's a new system that has sensors embedded in that seed firmer. So as we are planting, we are generating information, soil temperature. For the early planting, that could be a really, really important factor. Moisture content, by all means, is very, very important too. And we have 2 chemical characteristics of the soil. I don't know how they measure that, but that's organic matter and CEC, that's cation exchange capacity. Right. So those are things that are coming. This is even a more difficult because the usefulness of that system will be on a real-time adjustment. As the machine is going, gathering information, then how we make that system reactive in real time. Okay, but that's still far away. We need to do a lot more research before doing that. At the moment, I'm relying on the expert telling this is how I think this field should be treated, and these portions of the field should be treated. We can do that with technology, no question about it. Exactly. Yes, yeah, because that is only a mechanical system, and I know that will react to the instructions that we get. But how that translates to the biology, the agronomy of the crop, that's beyond me. But I guess even people like me can learn and go from there.
I mean, Pedro, the work that he's doing is so important for us because we used to get help from equipment manufacturers with field people and everything. And this technology on these planters, we just haven't seen it. Nobody is promoting it to us. I saw it at the Memphis Gin Show 3 years ago that Precision Ag company had a display that had planter units sitting there that they had retrofitted, taken an old John Deere planter and retrofitted all of these pieces on it to make a fantastic precision planter out of it with equipment that we've never seen. And the work that you're doing to let people know about things that are available, and then we need to know how important it is. That's starting to tell us a lot already, the work that you've done. So it's very important what you're doing and to get the information out and to try to get some of the manufacturers or dealers, because we're kind of a small market. They're not really very important in their world. They're selling it to all the corn and soybean guys.
They're not corn and soybeans. They're not corn and soybeans.
So it's very important.
Thank you, Ron. Thank you.
I was a freshman in college back in the 60s. We had a teacher over in Glendale, and he had been the ag teacher at Austin High School. His name was Clair Decker. And we had this one class, it was a 3-hour class with a 1-hour lab, and it was called crop science. And one of the big things that I remember that he did that still back in my life, talking about temperature, moisture, the condition of the soil, the temperature of the soil, all that stuff. And that actually where he was working with that planting depth is right where you're at now, but you're doing it with a much more sophisticated method than what we have.
What we have is control. It's really mechanical and electrical.
This is the guy that he wanted out there. He wanted to see what the hell was going on.
But part of the issue is what we're doing is we're substituting tillage that we were doing before with with a field. And if we have a planner that will do a lot of those things for us, then that's what we need now, because we're not doing the tillage to make it work.
But it all started back with some of that basic stuff that I reverted back to. I still think of that today.
The basic principle, Bruce, will apply always. But the times are changing, and we have different conditions, and we need to be moving in that direction. So I guess too much time. I'm sorry.
Yeah, that's okay. It's a good discussion. Thank you, Pedro. Okay, now we'll have Alex Hu, and he will discuss with us some of the cotton fiddling disease.
Yeah, it's the other way around.